For the following several videos, we will talk about some recursion examples. We will work on some recursion examples together. We will try to come up with our own recursive solutions for different kinds of problems. We will have live coding sessions in the following several videos. So if you want to follow along with me or code along with me, you could just bring up your IntelliJ. We can work on those recursive problems or the problems that we could use recursion to solve together. Okay, so the first question or the first problem that we would like to solve is we want to have a recursive function to find the smallest element in an array. So we know that using iterative solution, it should be very straightforward, but we want to develop our recursive thinking skill. So we want to come up with our recursive solution to solve this problem. So how we can do that? So for this question, we will assume that we have a precondition that we have at least one element in the array. Otherwise, how I could get the smallest element if I have the empty array? What should be the smallest element in the array, right? So we don't know that information if our array is empty. So we just have this precondition that we have at least one element in the array. So now let's just try to come up with our function prototype or function signature. So we want to have this public static. We know that the return value should be the element. Let's say we want to pass in an array of integers. So the return results, the return value should be integer as well. So we want to have a smallest element. The input should be an array, right? So we want to have an integer array. So is this enough for our function signature? So if we just pass in this array as the parameter, how could I reduce our problem into subproblems? How I can solve our original problem by solving the smaller identical subproblems? I cannot reduce this original problem if I just pass in this array as single parameter. So think about maybe the best way for us to pass in another parameter. Maybe I could pass in the length of this array so that whenever we look at the subproblems, we look at a smaller subarray by decrementing that length of the array by 1. So what I mean here is we could have an additional parameter which is n, and this n represents the length of this array that we pass in. So if we look at the definition of our smallest element function or recursive function, we would say this is that we want to find smallest element in the array of length n. Okay, so that's the definition. And whenever we want to come up with our own recursive solution, we always want to give a definition to our recursive function so that later we can decompose our original problem into sub-problems easily. Because we know what the definition of this recursive function, we know what the input should be, what the output should we expect, so that when we decompose it to be the subtasks, it should be easier and straightforward. Okay, so that's why we want to have the definition for this recursive solution or for this recursive function. So now I have this array and this parameter m pass in. So now what we should do? Think about. Okay, we know that for each of those recursive function or for each of those recursive solution, we have two components. Two very important components. The first component is the base case. Okay, or base cases, because we can have one or more base cases. Okay, so the second component should be the recurrence relation. So now let's look at our example here. Let's just have an example. array example. So for example, we could have 4, 12, 11, 92, 31, 2. Okay, so let's say we have 7 elements in this integer array. This is the input, okay, and we want to get the output. I know the smallest element inside this array is 1, so this is the output 1. Okay, so what's the base case should be? That's to say, what should be the simplest instance of this original problem? Okay, we don't need to do any recursive call, and we can get the answer directly. What's the simplest case? Okay, so think about maybe if I just have one element in an array, that I know that element should be the smallest element in this array, right? So that should be our simplest instance of the problem. So when our array has single element, that's the smallest element we're looking for. Okay, so how we can express that, how we can implement this in Java programming language. Okay, so think about, we have this n, right? This n represents the length of the array that we passed in. Okay, so if we only have single element, that means n is equal to 1, right? So if n is equal to 1, what we do, we just return the element at index 0 because we only have the single element. So we could return array 0. That's the element that we want to return. That's the smallest element in an array of length 1. That's the general idea. Okay. And that's the base case. And that's why we want to have this precondition that we have at least one element in the array. Okay, and what about the recurrence relation? How we can establish our recurrence relation so that we can eventually reduce our problems into sub-problems, and eventually we will get to our base case. Think about that. Okay, so we want to decompose our original problem. For example, we want to look at, initially we want to look at the smallest element method on our original array of length n, okay? And that's to say, I want to look at this array with 7 elements, and I want to get the smallest element, which is 1. That's the original problem, okay? Okay, so I want to decompose this original problem into subtasks. How could I do that? And for this decomposition, we want to solve a smaller identical problem, right? So how could I do that? Think about, maybe we could look at the array of length n-1. So maybe we could look at this array, okay? We could use this as the input. And I know I could call this smallest element recursive function on this smaller subarray, and I know the output will give me back 1. Okay, so this is the smaller sub problem. That's to say, we want to call this smallest element method on an array of n-1. The length of this array is n-1, right? So that's the first task. subtask we want to decompose this original problem into. Okay, so that's not enough because we just look at the first 6 elements in our original problem. We still have the last element left out. We need to do something for that last element, which is 2 here. Okay, so what we want to do, we want to get that last element, which is array m minus 1, right? That's the last element actually is at index always 1 less than the length of the array. So we want to get 2. So this will give me back 2. So these are the 2 sub-problems that we could decompose this original problem into. So what's next we should do? We have these 2 subtasks. Now what we could do is we could compare the smallest element from this subarray and the value of the last element, right? So we want to compare the value from subtask A and subtask B. We want to get the minimum value and return it. Okay, so that's how we can establish our recurrence relation, how we can decompose our original problem to find the smallest element inside of an array of length n, first into find the smallest smallest element inside of this array of length n minus 1. We get it, and then we compare it with the last element which we are left out. Okay, so these are the 2 tasks that we have to operate on, okay, and then we want to compare the value from the first subtask and the second subtask, and we just get the minimum value and return that value. So that should be our result. So we get the idea of how we can decompose our original problem into the smaller subtasks, and we could establish our recurrence relation and how we can convert that recurrence relation that we get into our Java programming, our Java program. So let's look at it together. Okay, so now I know that I could get the smallest element from our array of length n minus 1. That's to say I want to get the smallest element from this array with of this array with only 6 elements instead of 7, which is the strip away the last element. Okay, so we want to get the smallest element from this subarray, and we will get 1, which is the result. Okay, so have a faith in your recursive function when you do this definition. So that's why we say the definition of this function, recursive function, is very important, because when you look at this recursive function, you know that the definition of this recursive function would be find the smallest element in the array of length n minus 1, and you will expect the output of this recursive function will give you back the smallest element of this subarray, which is 1 here. And what you want to do here is we want to compare this smallest element from the subarray with the last element. Okay, so this is how we can decompose this problem, and we can use this math.min to do this comparison. Okay, so this is what we do, and we could just return the smallest element that we get. Okay, so this is how we can decompose our original problem into different subtasks into a smaller identical problem. And when we do that, we know the definition, we get the output we expect, and we compare this result from the subproblems with this subtask. And we find which one should be the smallest one, and we return the value. So that's how we can construct our smallest element method recursive function. So if we just look at our main method, let's say we want to have an array. Let's say we just have this array here. Okay. And I want to call the smallest element by passing array, and the length of it should be array.length, right? So n should be array.length. Okay, and what we will get, we should get 1 as my result. So let's see it. Okay, so there's the smallest element inside of this array. Okay, so that's how we can solve this kind of problem. And now we talk about the tail recursion, right? We want to have more efficient recursive solution. So in this video, we will talk about how we can also like convert this pure recursive function into the tail recursive function for the smallest element problem. Okay, so let's just have our static integer smallest element tail. Okay, so for this tail recursion, we say that all the other things are the same. Okay, what we could do here is, I know I should pass in the array. I know the array length should be n, but we should have an additional argument, which is the accumulator variable. Okay, so we could have an integer minimum value accumulator variable. Okay, so that's how we can construct our method, the tail recursive function signature. We have additional argument, and this argument actually is the accumulator variable. And we will look at how we can make a change, update this mean value, and eventually we'll get the correct result. Okay, so that's for the smallest element tail recursive function signature here. Okay, so now we want to convert the base case into the base case of our tail recursive function, how we can do that. So if n is equal to 1, what we want to return, we no longer want to return array 0. We want to return, so as we said, we want to move out, we want to move the components of outside of this recursive call into our recursive function as parameter. And when we reach the base case, we could get that accumulator variable and do some operations. So for this accumulator variable, we want to do the operation math.min. We want to move this math.min into the recursive function definition as a parameter. Also, we want to move it into our base case, just like our factorial and bad ideal method. Okay, we did the same thing. We just moved the components both inside of our base case and inside of our recursive tail recursive function as the parameter. So what we want to do here is we want to return math.min. Okay, so we move this component into the base case, and we want to compare array 0, which is the original return value, and the main value here. Okay, so that's what we want to return. So what's the recurrence relation? We want to convert this recurrence relation into the recurrence relation inside of our tail recursive function. How we could do that? We said we could move this math.min, which is the component and the component here. Okay, we want to do the comparison for the component outside of this recursive tail recursive function. So what we could do here is we could move both inside of the tail recursive function. We want to compare this array n-1 with this mean value. Each time we just update this mean value after the comparison. Okay, so what we can do here is we want to return smallest. So remember, our recursive function call actually is the last thing you want to do inside of this function. Okay, so nothing else. We should do something inside of it, not outside of it. Okay, so we still have the array, and for this n, this is the normal recursive variable. We just want to keep updating it, keep decrementing it by 1. So eventually, I will reach the base case. That's the general idea. But what about the mean value? Okay, so how we can keep updating this accumulator variable mean value? Okay, so we said that we want to move the component, so method min and array n-1, both of them are the components outside of this pure recursive function. So we want to move them inside of our inside of our tail recursive function. So we want to move it inside. We want to move this comparison inside of this tail recursive function as a parameter for this accumulator variable. Okay, so just like our bad ideal, we move the addition into our tail recursive function, just like our factorial will move the multiplication into our tail recursive function as parameter. Also, we do that, move the components inside of our base case as well. Okay, so that's the general ideal, and if we test it, we should get the same result. Okay, so if we say smallest element array length, let's just use our array 0 as the initial smallest element, as the initial value for the accumulator variable. Okay, because we have at least one element which is at index 0 of our original array, right? So that's the general idea. So if we compare it, we get the same result, and the smallest element should be 1. So this is how you can convert this pure recursive function into the tail recursive function by moving the components inside of this tail recursive function call and moving it inside of our base case. Okay, so that's how we can come up with our pure recursive solution and the tail recursive solution. And in your lab, you also will do that for the Fibonacci number problem.